Hello everyone and welcome to the video. I'm starting a new series where I learn the very basics of Unity and C Sharp and pass them on to you. So far we have been looking at building games end to end, and while that's useful in understanding the overall picture, if you want to really understand and gain mastery, you really need to master your fundamentals, basically your wax on and wax off. With that in mind, I'll be learning very basics and I'll in turn create videos on those. So in today's video, we are going to take a look at the transform component in Unity. Some of the tools that we will be using is Unity documentation and ChatGPT. ChatGPT or any other generative AI tool like Gemini. While I like both of them, I prefer ChatGPT for coding, and these are really good tools to use for gaining the understanding the fundamentals. Just be sure to not to make them a crutch. You should always know the logic behind the code that you are writing, and that is the motivation behind this series as well. So let's get started. What is transform in Unity? Transform is a component that is used to store and manipulate the position, rotation, and scale of an object. So that's a lot of words. Let's break it down. The first one being component. What is a component? You can think of component as the basic building blocks in Unity. Try saying that thrice, basic building blocks. So if you select any object in Unity, you will have the transform component here. The transform allows you to access three areas: the local position of the game object relative to the parent. So in this case, where the position is relative to the sample scene, just think of it as x, y, and z coordinates right now. Then there's the rotation. What will be the rotation on x-axis, y-axis, z, how large it will be. Let's see that with an example. Let's create a cube. Go to the hierarchy, right click, click 3D object and create a cube. We are going to let it be named cube. We are going to try changing the position and see how the cube moves. So this is the x-axis, y, and z will make it go further or nearer. Similarly for rotation, and you can again try using x, but it's not that visible, so I'm just going to type in a number like let's say 45, 45 and 45. So as you can see, it's rotating along the axis that's mentioned there. And finally scale, you can make it bigger or smaller, it's all up to you. Alright, so let's reset it. Right click it, click on reset. Now to understand the concepts better, what I want to do is try to rotate this cube. So that's the task that I'm giving myself. Idea is to create a cube and then rotate it, for which we are going to use the transform dot rotate. What does transform dot rotate do? Let's see. Let's take a look at transform rotate Unity. So you use transform dot rotate to rotate an object along an axis. Hopefully the concept will be more clear when we see it in action. Now the next thing I want to do is create a code, and the way to store that is right click here at the bottom and then project create a C script. Let's name this rotate cube and let's bring it up. Let's first let it load and then load it up. Now it didn't seem to work. Let's try that one more time. Okay, perfect. Now This is basically where your code will reside, and the first thing that I'm going to do is create a variable to store the rotation speed. Then I'm going to link or apply that speed to the cube we just created. So let's create a public variable. There are two types of variable, public and private. Private has only local access, but public can be accessed from anywhere, so you should be careful when creating a public. For this example, I'm just going to use public. It's a short example, doesn't matter. And then you have to decide the type. There are different types, like as we know from school, there are like integers, decimals, whole numbers. This is going to be decimal, and that's called a float. And we are going to name it something that's easy to remember, like rotation speed. All right, next thing we're going to need is apply this rotation speed to the cube, and that's where transform dot rotate comes in. Now notice the spelling. There are two variations of it, with a capital T and small t. The small t is, if you use the small t, it means that it's applying to the current object. So what do I mean by that? There can be a new instance. So this code here has a rotation speed, but how does it know how to apply that speed to the cube? We go to the cube and drag and link that script here. Okay, that's not working. Let's just do it from here. Apply rotate cube. Why is this not showing up? I don't think that worked. This doesn't look right. There's no space here. Okay, let's give it a try. I'm not sure if that actually applied, but the idea is that in this game object you have attached the script. That's why now this script knows that it's going to apply whatever I write here to this game world object. Hope that made sense. Now let's take a look at transform.rotate. Transform.rotate has three axes, x, y, and z. We don't want to rotate it along the x-axis. We don't want it to rotate it along y-axis. We want to rotate it along the y-axis. That is a horizontal rotation along a vertical line. And we are going to apply the rotation speed here, so let's mention that. However, we haven't assigned it any value. Right now we have declared the variable, but there's no value assigned to it. So let's just apply 10f. F simply means float or decimal, and let's see what happens actually. It's compiled, that means it worked. Now click on play at the top. And it's not rotating. Oh, did it rotate? It rotated once, so it worked once for one frame, and I can see why. If you read here, this whole thing inside these braces is the key code, and that's executed only once inside this function start, because it's called before the first frame update. However, we want to apply the speed every frame, so we'll have to move it to void update, which is called every frame, so it will have a more smooth rotation. This would work. Let's give it a try. Okay, that's way too much. It had a fit. Let's reduce the rotation speed, so let's say 1f. That's still a lot. I don't know what frame per second my Mac is, but it's way too much. Let's try decimal points. Hopefully that will be much more smoother. No, still too much. Okay, so what we are going to do is use another concept, which is time dot delta time. Now, so the reason I'm doing it is to see if I can have some better control over the speed, and let me try to explain this concept. So right now we know that the void update is being called once every frame, and one frame can be anything, right? It can be 1/10 of a second, depending on the speed of your computer and your settings. So what we are going to do is just assume that currently the speed of my Mac is, let's say, 1 frame every 5 seconds. Speed of, let's move it to the top, current speed of 1 frame every 5 sec. So there will be here at the starting, then at 5, 10, 15, 20, 25, 30. So these lines indicate when the frame is being rendered, when this function is being called, the rotate, and every time that function is called there's a rotation. But however, and my Mac is, let's say, has a frame speed of 1 frame every 5 seconds. Someone else's Mac, others computer, may have a much lower rendering speed, so it could be 1 every 10 seconds. In which case it will be much slower for them. So what we do is multiply it with time dot delta time. Let's look for that. Time dot delta, the delta time is the interval in seconds from the last frame second to the current one. So what we are doing is basically stabilizing this, or taking control of the speed at which this object is rotating. So let's go back and let's just copy this here, time dot delta time. Where did it go? Yeah, okay, so we already have it, and let's see if that smoothens things out. Close that. Okay, there we go. We have a very beautiful smooth rotation, and hopefully that helped you understand a lot of concepts. We covered quite a few concepts today, very basic, very fundamental. We covered the concept of transform, under which we covered rotate, and I'm going to give you a homework at the end, which is to play with position. Let me get back to that in a second. We looked at transform, we looked at what components are, we created a game object, cube, we looked at time dot delta time, not delete, delta. We looked at function and calls per frame. So hope this video was helpful to you. Now, as a challenge, I recommend that you play with position. I want you to uh, print the position of the cube that we just created, and the way to print the position is use the command debug.log. So go ahead and pause the video, try to print the position of the cube, and I will try to do the same in a second. Okay, so let's go to Unity, let's go to our code, and instead of transform.rotate, we'll only for once, like we don't want to keep on printing every second, only once print the position. And for that, all I will do is replace transform.rotate with transform.position, and let's see what happens. It may not work, but let's try that. Debug.log transform.position. Let's see if this first of all compiles, and then if it works. Oh. Transform does not contain a definition for position. Okay, let's look up transform.positions syntax. You was transform, yeah, you have transform. The p is small, maybe let's try that. If not, we'll create a vector3 and then print it. Yeah, let's not worry about that right now. Let's just simply use transform.position, no brackets, make the p small. Let's see if it compiles. Yes, let's click on console so that we can see the output. Click on play. Yep, you got the position, which is 0 0 0. So that worked perfectly. Now I'm just curious, and since this is for learning, I want to change the p to capital and see if it still works. No, that's an error. So that's pretty interesting. The earlier rotate had a capital R, but this one uses small p. But yep, so I hope you like the video. Please like and subscribe if you want more such content. Thank you.